Hi, I'm Eric Kelsey, Professor of Meteorology at Plymouth State University in New Hampshire, and I'm here to talk to you about guidelines for helping you select a site for launching balloons during the nationwide eclipse ballooning project. All right, the first thing we should do is look to see what the World Meteorological Organization and NOAA and the National Weather Service have for guidelines on site location. And as a matter of fact, they don't actually give any guidance on site selection. And that's because the primary purpose of weather balloons is to measure the atmospheric conditions away from the surface. So some Weather Service offices actually launch their balloons from rooftops. One example of the National Weather Service in Gray, Maine, where they launch their balloons is what they do is they prepare their balloon in the garage, as you see here, and then they carry the prepared balloon out on a driveway about 50 to 100 feet away from the building, and then they release the balloon. For research campaigns, this is one that I led a few years ago. We made sure that we were near a building actually for power purposes and restroom facilities and things like that. And then when we released the balloon, we made sure we did that a safe distance away from the building and from trees, and we were able to get good measurements. Ultimately, it's the scientific questions that should drive where we launch weather balloons. So we have two major scientific questions. One is, how do the eclipse shadows impact the stratosphere and the generation of gravity waves in the stratosphere? And the second question is, how does the eclipse shadow impact the planetary boundary layer, or the lowest, roughly 2 kilometers of the atmosphere? First, let's take a look at stratospheric data. The launch site conditions, as I mentioned before, are relatively irrelevant for taking stratospheric measurements because the stratosphere is so high up there that the surface does not have any direct impact on the stratospheric conditions. The biggest thing we need to be concerned about is making sure that our site locations are far enough away from large mountains and other obstructions such that as the balloon gets up into the stratosphere and has had a long time to drift far horizontally away from the launch location, that there aren't any large mountains or other obstructions that get in the way of the line of sight communication between the balloon and the receiving station where we're located. So just make sure of that, and we can use Google Earth and other things to help you figure that out. Now, we do have a lot of mountains in the 2023 October annular eclipse path, as you see here, a lot of mountains in the west here to make sure that we're a safe distance from, several miles away from. And the other thing to think about is that we need to have a good spatial distribution of stations here so that we can measure what sorts of stratospheric gravity waves are being generated from the mountains themselves. So as the atmosphere passes over the mountains, gravity waves can develop, and we want to get a good background state of what those mountain gravity waves look like. So by placing sites or teams up here by the Pacific coast and then down across the Rockies and then down here towards the Gulf Coast, we can capture what those mountain waves look like prior to the eclipse so that when we do measure gravity waves generated by the eclipse itself, we can figure out which gravity waves are generated by the mountains versus the eclipse. For the April 24 eclipse, you can see here, it doesn't go over too much in the way of mountains, but there are some mountains here in the northeast, and we also have some mountains down here in the Ozarks, just to be mindful of those when choosing a location. All right, when thinking about the boundary layer, we're gonna have a surface weather station continuously measuring temperature, humidity, pressure, wind, and radiation. So we'll capture that just fine with our Luft surface weather station. Now the planetary boundary layer changes due to surface conditions on the order of minutes and up to an hour. It responds very quickly. And so we need to be mindful of the ground conditions that are then driving how the planetary boundary layer responds to the eclipse and responds to sunlight and nighttime. And these boundary layer conditions, its temperature, its humidity, the wind, its depth, are controlled by things like the surface type and the vegetation. Are there trees? Is it grass? Is it desert? The roughness of it, right? How big are those trees or vegetation? Are there any buildings or other structures around? Hills, mountains, all of that impacts the boundary layer. Also moisture and albedo and the slope of the land. All of that impacts the ground conditions and ultimately what the boundary layer does. Now, as the solar radiation comes in, it can do one of two things. It can either heat up the ground, as it does here. Now, this is Manchester Airport in New Hampshire, and the Manchester Weather Station is located in this small grassy area surrounded mostly by pavement and concrete, right? There's the runways, there's the terminal building, a lot of artificial surfaces here. And because these artificial surfaces are typically dry, nearly all of the sun's energy striking this area of the airport goes into heating those surfaces, which then heats the air and heats the boundary layer. But some of that energy in a more natural environment, like a wheat field out in Montana, now granted this is agricultural land, so it is being maintained and whatnot. But since we have vegetation here, some of the sun's energy does go into heating of the ground and of the wheat, which heats the air, but a lot of it also instead goes into evapotranspiration. So evaporating moisture from the soil and also transpiration from the vegetation itself. So because of this vegetation, it helps to keep the boundary layer a little bit cooler because some of the sun's energy is going into evapotranspiration as opposed to paved surfaces in which all of the solar radiation is going into heating of the air. And we want our location to be a more natural surface, to be representative of the surrounding areas. We also want our launch location to be relatively flat in a 25 by 25 meter area or so, or roughly 100 feet. So make sure that you set up your site on a level place. If there was a slope to the south, then that means it would get a lot more sunlight, direct sunlight, and therefore it'd be warmer than average across a larger area. If it was a north-facing slope, then it would get less sunlight, and therefore it would be a cooler location on average than the general area of that location. So getting your site located in a nice flat place will help to homogenize or get the best representative location of that area. We also want to set up our sites where there is short vegetation, so grasses and other things that are generally less than 2 feet or so in stature are great. Now here on the right side, we have more of an arid region, right, with some very dry and low stature vegetation. Maybe you'll end up launching from a desert itself with no vegetation. That's fine. A representative surface of that region is what we're looking for. For the 2024 eclipse, the path crosses over a lot of forest, but we don't want to be launching from within a forest because the balloon obviously will get tangled in the trees. So in those cases, find a nice open clearing that has some vegetation on the ground. Grass is great, and that will be a sufficient location to get representative boundary layer measurements from our surface weather station and from our balloon. Some other things to consider are obstructions that might cause our balloon to get caught. Right? When we release our balloon, will likely be some sort of wind causing it to drift, and we want to make sure we release our balloons far enough away from obstructions to not have that problem. Over here on the left, we have trees that are a little too close to these instruments back here, for example, so we also want to consider setting up our left weather station far enough away from trees as well, so we aren't capturing this battle between the clearing conditions and conditions that are representative of within the canopy or under the forest. The instrumentation here in the foreground is far enough away from the tree, so that would be a better location here. We also want to avoid conditions that are disturbed. Right here it looks like there were vehicular, maybe construction vehicles that passed through and caused rutting, and then it rained, and so it created all of this puddling here. We don't want to set up our weather station near there. A little further back, it looks like it's less disturbed or undisturbed with some low vegetation, and that would be a better place in this particular site to set up our surface weather station and launch our balloons. We also want to make sure that we set up our weather station at least 50 to 100 meters away from pavement and other large artificial surfaces and bodies of water as well. Now, we might not be able to avoid an isolated tree or bush wherever we are, and that's okay. If it's only a few scattered trees or large bushes, just make sure that the surface weather station is set up a good 10 meters away from those. Same thing with, say, a concrete path or a small body of water, things like that. Any sort of artificial surface or body of water, just make sure that the surface weather station is set up a good 10 meters away from those, and it will be measuring good representative conditions of that environment. All right, here's some ideas of some great places to set up your launch site. Athletic fields are terrific, right? They're big, grassy areas, so no matter what part of the country you're in, if you can find a good grass softball, baseball, football field, right, that should be terrific. The trees are far enough away. In this case, the warning tracks are small enough, and so are the fences, that that's not a big deal. Again, just make sure that the surface weather station is located 10 meters away from those, and those are great. On the other hand, we want to avoid artificial turf fields, like this football field here. Now, even if this was a natural field, natural grass, this still would not be a good location for a number of reasons. There's the rubber track that goes around the football field. There's also the concrete tennis courts. There's also this giant paved parking lot. And on top of all that, we have light stanchions. There's 4 light stanchions surrounding the football field. So we have a lot of things going against the site, and these are features that we definitely want to avoid when finding a location to set up our sites. Here is an aerial view from Google Earth of Santa Fe High School, which has a couple of turf fields that you can see here, these dark green fields. But then we also have a baseball field. And we want to avoid the artificial turf fields, of course, so don't go there. But even though this field is brown, right, this is the natural environment, or a more closely natural environment than artificial turf. It's a fairly arid climate, and so the grass is not going to be green most of the year. So go for it. That's a great location when we're looking at places in the western US for the October 2023 eclipse. The road that goes by here, it's far enough away to not worry about it. It's also very narrow. So all in all, that baseball field is a very good place for launching balloons. And in general, right, generally speaking, grass, baseball, softball, football fields are great. You want to make sure there aren't any light stanchions or any power lines running by, right, things that might catch the balloon. Also, town recreation fields and parks can also be good, but those vary town to town, so look into it if that's something you want to consider. Also, high schools, right? High schools have a lot of great features. They have these great athletic fields. They also have a place to store the helium ahead of each eclipse. So that's something that we need to have. They also have teachers and staff that will likely be willing to help take in that helium, and also organize students from their school to come out and talk to us so that we can broaden our outreach through our project in that way. They also have restroom facilities, and maybe if you need a place to sleep during the campaign, you might be able to go into a room in their building and take a nap. It will be a long campaign for sure. All right, when releasing a balloon, we want to make sure that we release it so that it won't get caught on anything, trees, other obstructions. And so when doing so, just look at what the wind is doing in terms of its speed and especially direction. And you want to launch on the upwind side of the field so that you give the greatest distance possible between where you're launching it and any obstructions downstream, downwind, that the balloon might catch on. So trees, power lines, light stanchions, things like that. Just make sure you're as far away from possible in an upwind direction when launching your balloon to do that. Now, especially for the April 8th, 2024 eclipse, we may still have some snow on the ground, especially in the northern part of the eclipse path. And that's okay. Be prepared for it. Make sure you bring warm socks, boots, lots of layers, right? Maybe some heat packs that you can throw in your gloves, things like that. And in terms of setting up your location, you're setting up your surface weather station and releasing your balloon, you can pretty much ignore what the snow is, even if it's patchy. You can locate your ballooning equipment and your tent if you have one, and tables where it's most convenient. And you can do it on the bare ground, provided that the ground isn't soggy and that you don't make a big muddy mess out of it when you're there walking around and standing there a lot. So as long as the bare ground is relatively dry and not going to turn into a big muddy mess, then go for it. Set up your tent there and your equipment there. But if it is a bit soggy, then just move everything onto the snow so that you don't have to worry about doing that. Also, when you locate your left weather station, you can do that pretty much anywhere, just following the guidelines to make sure it stays away from obstructions where things like fences or bare pavement, bodies of water, things like that. You can go with the prior guidelines I described when setting up the weather station, and you'll be okay. Lastly, we want to make sure that we document our site location features very, very well so that we can best interpret the measurements that we collect from the surface weather station and the weather balloons. So here's a form that you can find on our webpage, and we'll make sure you get it. And fill this out when you get to your site. And let's step through it so you can see what to do here. Right, you'll have a team name and the dates of the launch, the location, right? Is it Santa Fe High School? Where is it? The town, the state. And grab some good coordinates and elevation data from a place like Google Earth and fill those in so that we can pin that on a map when we need to. Further down the form, we have this where you can fill in what your site looks like. So here's an aerial view here on the right, and the weather station is put in there. So put in everything else relative to the weather station, including where you set up your launching equipment, your laptops, tent if you have one, put that in there. Where you release balloons, and maybe you'll because the wind's changing, you end up releasing the balloon from different locations. Go ahead and just draw in more than one balloon then. Any buildings or structures, roads, trees, bushes that are isolated, and also draw in any forest that's there as well. Any obstacles, draw in your best estimate of what their height is in meters. And then elevation, right? Are there any slopes around here? Obviously, we want the innermost portion of your site to be flat, but maybe as we get further away, there is a hill going up or down. Water. We also want to make sure that you document water, any ponds, streams, lakes, or even puddles that are just there for a long time, big puddles. Make sure you document those as well, because those will impact our surface weather conditions. Towards the bottom of the form, we have this graph here, where you will draw in a continuous line showing the height of any sort of features, obstructions, trees, buildings that are sticking up and covering some portion of the sky above the horizon. So draw a continuous line, maybe it'll look something like this, so that we know how much of the sky in a 360 view was obscured by things like buildings and trees. So do that, and then lastly, take pictures. So with the surface weather station right behind you, take pictures from the 8 main cardinal directions. Right, take a picture looking north that gets some of the ground in front of you, and then the horizon and the sky. And then take a picture to the northeast, and then to the east, and so on around the 8 main cardinal directions. And then you can upload those. We'll tell you where to do that, so that we have good visual information on what the site conditions were at the time. And that'll help capture what the snow conditions were as well, if there was snow on the ground. All right, well those are the guidelines for site selection. If you have any questions, here's my contact information and here's our webpage. And I hope you have a great time launching balloons.